as we are we getting into the actual item? Where is it? Let's see. Yes.
Okay, it's 10:50. We're back. This is John McCann again. Before I jump into the slides, I want to give folks on the phone one more chance to maybe unmute and ask any questions that they might have. Or Boris, if you're on, I don't know if you would have gotten any chat questions on your side, but we didn't see any pop up over here.
Yeah, I didn't get any either.
Okay. Well, if everyone is okay with where we are, we're running quite a bit early, which is unusual, but awesome considering we're doing this webinar on a Friday. So we're going to get into some concepts here for hydrology, for Lotic systems, and then we're going to jump into the actual items on the form that used to be called a checklist, the yes, no, NA questions. Oh, hitting the wrong button here. Get back over to the right spot. Okay. So again, this step one here is to assess the function using the PFC protocol. So we complete the field assessment with the 17 questions, the 3 legs of the stool there, answer yes, no, or NA, no liners, and we want to put notes for everything, because when you move on to a different office and the next team comes in and says, well, what the heck were they looking at, just a simple yes or no or unchecked box or a liner isn't going to give them real good information to figure out what was going on when you saw it and what changes may have occurred between that time and now. So this idea of floodplain, we've used this term quite a bit, and we just want to kind of get into some of the details of this to make sure we're all on the same page. So morphologically, a floodplain is a level area, it says near the stream channel, but starting at the edge of the stream channel. It's constructed by the stream, or more correctly, the sediment that's carried by the stream, but the concept there that it's constructed is very important. Floodplains are depositional features. If they're eroding or downcutting, then something has changed, either management-wise or climate-wise. So yeah, in the present climate, right? So depending on whether you are a snowmelt dominated or spring fed or thunderstorm dominated, if that starts to change, then it's going to change the type of features that your stream is going to construct. Flooded during moderate and high flow events, right? So this isn't flooded every single year, but water hits that, you know, somewhere on the 2 years out of 3 or so. So bankfull events are what we're talking about, and the sort of midpoint of what a bankfull event is about a 1.5 year recurrence interval flow. That can be adjusted a little bit up and a little bit down, and how you get that recurrence is not by guessing. You really want to go out to stream gauges and measure where that feature is, and then check that against the historical flood data for that gauge, and then you'll find out what the discharge was, you know, at that stage, and then you can correlate that to a recurrence interval based on historical data. And then we don't want to confuse floodplain with the word terraces. So usually terraces that you see, or the word terrace in this instance is used to relate a feature that used to be a floodplain. So it was a feature that was deposited by the river adjacent to the channel, building a floodplain. But since then, there has been some reason for that stream to downcut, and then it may have been cut laterally as well. But that feature that used to be a floodplain is now referred to as a terrace. And that downcutting doesn't have to be significant. I mean, it could be you downcut just a couple of inches, and now that floodplain level is lower than what that terrace is, based on what, as long as your discharges haven't changed. So we need to be careful in describing things as a floodplain or a terrace. And you can have multiple terraces too, depending on what landscape you're in. You may go out of your channel and be on a floodplain, then you may hit one terrace that's about 2 feet tall, you may hit another terrace past that that's another 2 or 3 feet higher, and then, you know, how tall that terrace is, it changes from site to site.
Terraces could also be part of, say, a 100-year floodplain hydrologically, not geomorphically.
Correct. So if you couldn't hear Sherm there, so a terrace may be part of sort of a 100-year floodplain. So we talk about, you know, the 1.5-year or the 10-year, 5-year, 20-year, whatever flood. So all of those encompass an area once that flood gets up and out of the channel. But when we're talking about this feature that's being actively created by the stream, and as you can see in this example here, we're looking at the floodplain level that's built by about that 1.5-year flood. And that's all it takes to get up and out of that. But some of those terraces may be at a level where they would be covered by a much higher flow. So in this example here, we've got a sinuous stream, and we've got 2 meander bends here, and you can see the bare point bars on the insides of the bend. And as you move upland or away from the channel from the point of that point bar, you can see that vegetation is kind of giving you a record that that point bar has been slowly marching out. The vegetation has been slowly following it. So we're getting deposition of sediment there, creating that new floodplain, which is then being occupied by that vegetation. So if you want to try to get more into this, it is a very important concept. If you haven't spent a lot of time out on streams looking at floodplain or bankful features with people who are have already been doing it, it can be a little confusing. It's easy to make calls that are either a little too high or a little too low, depending on what time of year you're out there. But here's if you go to this stream.fs.fed.us, they've got some materials there that are available, and that photo there for a guide to field identification of bankful stage in Western United States. That's Luna Leopold, who was kind of the coach, the teacher, the guru for Dave Rosgen. So a lot of Rosgen's work came out of what he learned from Leopold. But there's actually a video that you can watch on YouTube where it's got Luna and a couple other scientists talking about what bankful is, how it works, and how you can identify it in the field. So if you haven't done that, I'd really suggest going ahead and finding that video and taking the time to watch it. So what are we looking at when we're out there? We want to base the idea of where bankful is based on field observations, not just on, okay, well, we went and looked at the stream gauge data and we found what that 1.5-year event was, because that 1.5-year event is not always going to be correct. So we want to look in the field and see what it is. Again, we're looking for depositional features that are fairly consistent as you move up and downstream. So you can take a level out with you, or you can take you know, a walking stick with a little level on it, just tape it on there, and go to those things that as you come up out of the water, you find a flat feature. You measure how high up off the water that is, and if you walk a couple of meander bends and you're consistently measuring something about, you know, 6 to 8 inches off the water, or you know, 3 feet 8 inches to 4 feet above the water, you know, whatever that distance is, then you're pretty well dialed in. But if you start seeing some that are 6 inches off the water, some that are a foot off the water, some that are 2 feet off the water, then you've got different things going on there, and you want to find that consistent feature throughout the reach. And as Sherm, I think, mentioned before, not all channels are going to have a floodplain that's being developed. So those A+, and A channels really don't have much of a floodplain feature at all, or they don't have a floodplain. They do have a little bit of a break sometimes there at a bankful stage. You get down into the B streams and they start to build some floodplain there. It's not huge and it may not be continuous, but you may see it occasionally throughout a reach. So just be mindful of that. Something else too is that we've seen here in Nevada, after 4 years of drought, so 4 years of lower flows can start to build features that look like a floodplain based on 4 years of lower flows and lower sediment. But you don't want to let that draw your eye away from something that may be just a little higher than that. Also, while trying to be mindful of the idea of climate change, maybe that lower feature becomes the new norm. And you can put that discussion on your form if you see that, but just try to make sure you don't see that lower thing during a couple of years of drought and say that's where it is. if you look at point bars on the inside of meander bends, usually they slope up out of the water and then they'll kind of break and turn flat. That can be a really good indicator of where the bankfull elevation is. Some mid-channel bars can kind of do the same thing, but mid-channel bars usually are an indicator of instability within certain types of channels. So while the top of them can indicate bankfull, you may want to be careful with that. You can look at scour marks along the edge of the stream on rocks or on trees. Again, being careful, figuring out where you are. If you're on a system that has a lot of ice rafting, that ice rafting may actually cause scour above where that bankfull elevation is. There are certain there's certain trees that will grow kind of right down to where that bankfull stage is, and they're pretty good at marking that. But again, that's not always a good indicator. So there's a lot of things you can look at, and you really just want to practice figuring out what that is and finding those USGS gauge stations, doing the math on the historical floods to kind of see about where that discharge might fall, and then going out in the field to find those indicators is a really good way to train your eye. So here's another example of a long-term hydrograph. So this one's on the Truckee River at Reno. So what we're looking at here, what we want to try to figure out is, okay, what are those high points in there, and which one would be bankfull? So it's hard to pick out of a hydrograph like this. What we want to look at is annual peak flows. So here's the history at the same site from just a little bit, or around 1950 to about 2012. And so there's one record for each year showing the highest flow that was recorded. And if you want to do sort of a quick and dirty back of an envelope sort of version of this math, you can just sort of estimate where about a third of those dots are below a line and 2/3 are above. And what that means is 2 out of every 3 points is going to be at, the line that you draw in there or higher. And that roughly equates to a discharge that is about a 1.5-year recurrence interval. So on this chart here, that's where that line would fall. So we're looking at about just under 2,000 CFS. So here's a slightly longer term set of maximum discharges at that site. So if you extend that a little more recently and back in the history a little further, that trend of about a third of them are below that line and 2/3 are above continues. So then we can plot that discharge on this long-term continuous hydrograph, and you can see that most of the flow throughout that history is below that line, but occasionally it does bump up and just barely hit it, or it'll jump up above it, come back down, or it'll jump up above it, stay there for a little while. But it's about that flow, that discharge, that's really doing the work to create any floodplain or bankfull features at that site. And so here's that same line plotted against just a 1-year hydrograph, and you can see that in the last year, so I think this is probably current up to this week at least, we've gotten over that point just twice, and maybe only for a day or 2 or 3 at a time. So we've had those flows this year. It's nice when you go out and do PFC to try to figure out if you hit that bankfull flow in the last year or last couple of years. Like I said, during drought, if you haven't hit it, then you tune your mind in to say, okay, the features that I see may be a little misleading and maybe a little lower than what bankfull really would over a more climate-related history, so over the last 30 years or so. So actually getting into the first item here, now that we've kind of cleared up a little bit of what bankfull is in regard to the features it creates and what the discharge means. Item number 1, it reads, floodplain inundated in relatively frequent events. You see there's some language in blue there that's been struck out. That is the way the question was written in the previous protocol. We wanted to include that language in here, but indicate the changes so that you know what changes have been made to the most recent protocol. So above bankfull was kind of taken out because, again, as I mentioned, at bankfull stage, that's where your water is hitting the floodplain that's developing in the current climate. So it's a little redundant to say above bankfull. And then that relatively frequent events, 1 to 3 years, same sort of a thing. You know, when we talk about what we're managing for, what we're looking at in PFC, relatively frequent is in that 1 to 3 years usually, but we didn't want to lock it in there. And then looking at those bigger events is sort of that 10, 25 years. So it's sort of a general discussion when we say relatively frequent versus larger events. We didn't want people to think it was a hard and fast, or you know, 1 to 3 years exactly. So why are we worried about this? For channel types that usually would have and should be developing a floodplain, that floodplain helps slow water down. As the water gets up out onto the floodplain, it's shallower there, right? So there's a lot more effect of the resistance of the vegetation, boulders, rocks, that sort of thing, roughness of just the floodplain shape itself to help slow that water down. It helps deposit some of the sediments, so then you get this balance of erosion and deposition down through the system. And as the water gets up there too, it helps improve groundwater recharge at, you know, on a site-by-site basis, but then also along the entire stream corridor, so that when the floods recede, you have an increased amount of groundwater that's going to slowly recharge back into that channel later into the season. And if you've had a channel that's in size, that's acting just like a pipe, when you get a high flow, instead of spreading out on a floodplain that stays completely in the channel, moves through the system much, much quicker. You have a much higher shear stress along the edge of the bank, so you get greater erosion, you don't get the depositional features, and you don't get the benefit of holding that water back over the season. Again, floodplain is the flat depositional surface adjacent to the channel. On C channels and E channels, they're very, very common. They're a very important part of that whole system for those two channels. For the braided and anastomosing channels, they can be important as well. Some of the B channels, as I mentioned, can have them. They may not always be continuous, but you may see some evidence. So what indicators of no are there? So an incised channel, so it's you know, vertical instability or erosion, and enlarged channel, so it's sort of the lateral instability or erosion. Vertical banks on the inside of bends and at straight reaches. So on the inside of bends, that's where we typically would expect to see deposition. And if you're seeing erosion where you've got deposition, then you know something's really out of whack, and you're probably getting too much shear stress in your channel itself. And then in the straight reaches too, the straight reaches, so the riffles of channels in streams that would have sort of a pool riffle sequence, those areas kind of show where you've got sort of a perfect balance of erosion and deposition. You know, you've got sediment just moving through that site and maybe replacing some of the gravel that's in there, but you usually don't get that channel moving downward through erosion or upward through aggradation. And then upland vegetation on the stream bank. If your site is drying out, you may start to see sagebrush, rabbitbrush creeping closer and closer to your channel edge. And one thing I want to point out is that this is a question that is a yes, no, or an NA. So again, if you're on an A channel or a C or B channel where a floodplain is not required for stability, then you can answer this as an NA. So here's just an example here of a stream that is flowing. So this discharge, you know, you wouldn't know unless you knew more about the site, but I'm going to tell you that the discharge in this photo is right at the Bankfull discharge stage. And at that stage, it's hitting right at the edge of that relatively flat feature adjacent to the channel. So in this instance, this would be a yes. And if you're lucky enough to be out at a site right at the Bankfull discharge and then seeing if it's hitting a flat surface next to the channel, that makes the question a lot easier to answer. But usually we're not out there at that time of year or right on the exact day, or with some of the flashier systems, you'd have to be out there right at the exact hour or even, 15 minutes or so. But you can look for evidence here in the foreground of the photo. You can see that fine sediment that's being captured in the herbaceous vegetation. That's indication that your water has gotten up onto that floodplain and you've gotten some of the functionality out of that floodplain feature to help slow water down, capture some of the fine sediments, improving water quality, adding to the water recharge of that adjacent groundwater. So item number 2, again, the blue struck outwards are how the question used to be worded. What's left in green is how it's now worded. So it currently says beaver dams are stable. It used to say where beaver dams are present, they are active or are stable. But if beaver dams aren't there, you can basically say it's an NA because it's not adding, it's not a risk factor for the site. If you think that beavers were never part of the system, that's an additional indicator to say NA. But if you do have dams there, no matter where they are, right, if they are stable, then you no longer have, or you don't have that risk factor. So it uses say active and stable, but the idea is if you have an active dam, usually you consider them to be stable, but that's not always the case, right? So you may have an active dam, it may be a brand new dam that isn't yet stabilized through, you know, a series, or it hasn't been tested against high flows. So we just want to know, if beaver dams are there, are they stable? The other side of that is you can have an inactive dam. There are beaver dams that have been created but then have fully revegetated, either with herbaceous or woody species, and they may not be active anymore, but they're still stable because of the root structure of the vegetation that has moved in. So when you're looking for sort of indicators of activity, the dams are usually pretty dynamic themselves. You know, beaver are backing water up, so the water wants to go up and around, and the beaver are continually working to help stem the flow of water around it because they don't want that to erode and blow out. So you'll find newer sticks around the edges or in the middle where the water may be going over. You'll usually see evidence of sort of food stock, you know, type of sticks and twigs around that seem freshly cut, that are laying in the water or adjacent to the water. You'll find stems or stumps on the banks that have been freshly cut. You know, you can usually tell stuff that's been cut this year versus last year. And then whether or not you've actually still got a food source or a dam building material source for the beaver around the dam. Some indicators of what's at risk, like I mentioned, if you've got a brand new dam or one single dam that's been put in by beaver, there's a potential for some risk there. It's not always the case. But when beavers build dams sort of in a series, it's sort of a set of fail-safes. So when you see multiple and they're active or they've been completely revegetated, there's a bit of a buffer against the risk there. If you see a little bit of end-around erosion and you don't see any signs of the beaver coming back to try to start some repair, there's some risk there. If you are in particularly confined valleys where if you have a high flow and there's no ability for flow to go sort of up and spread out around the beaver dam and all of that flow is going to be concentrated right on the dam itself, there's a potential risk there. Dams not anchored to banks, so this is a little bit of a judgment call to be made. There are some beaver that will be on larger rivers and they won't necessarily build a dam that goes 100% of the way across. They'll kind of build it like a log vein that kind of juts out a little bit, gives them a little bit of slow water next to the bank. Some of those are stable, some of them are not. And again, it depends on the channel morphology, the types of flows you may get. So there's some places along the Truckee River where over the last couple of years of low flow, beaver have come in and tried to do that sort of thing, trying to improve the habitat for themselves. But this year where we actually had some high flows, I haven't been out to see it, but my guess is that entire dam has been washed away. But that didn't impact the stability of the Truckee River itself because it had other features going on to allow it to be resistant to those flows. And then if dams are not stabilized by woody vegetation, so there's some cases where beaver will use just rock and mud, and if you're in a system where you're going to need a little bit more material than that, or you're going to need the vegetation to start rooting in to really be stable, but that vegetation wasn't there for beaver to use, then you could have an issue. Or if they're using, we've got an example, if the woody material for tree types that are adapted to that type of disturbance isn't necessarily there, beaver will try to use whatever's available. So in this example on the left, this beaver was trying to make the best with what he had, so he was cutting down sagebrush and putting it into a small beaver dam. And that itself, as the sort of beginnings of a beaver dam, we'd probably say that no, that's not stable, because there's no likelihood that that vegetation is going to start rooting in. That vegetation itself is not going to resprout and continue to provide a future source of material for that dam. So over time, it's likely that that dam is going to fail, even if the beaver is still there. On the right-hand side, we've got a small beaver dam that was constructed. It's got some end-around erosion, and there's no evidence there that the beaver has come back in to try to fill up that gap where that erosion is occurring, so that it's an inactive dam that is also unstable. Item number 3, sinuosity, gradient, and width-to-depth ratio are in balance with the landscape and setting, i.e. landform, geology, and bioclimatic region. The reason we want to do this is every stream has a stable type, if not maybe 2, maybe 3 stable channel types that could be there. And if you're outside of the range of what's stable for that type, then you risk losing the stability of the site overall. So if the vegetation's out, or you know, as we cross a threshold, we can lead to a mass unraveling. So if something is changing the pattern, dimension, and profile of the stream, it changes the stream power, it changes the erosion and deposition, and it can really lead to sort of an unraveling of the whole site. And again, if people aren't aware, sinuosity is the curviness of the stream, width-to-depth ratio. We look at that, and really we want to compare that at the, if it was a pool riffle system, you measure that at the head of the riffle, or the sort of the very beginning of the riffle. If it's a step pool system, you measure that across the step feature, not in the pool feature. So if you're familiar with Rosgen classifications and how you would go through that flow chart, it talks about the width-to-depth ratio. Those aren't measured in the deepest parts of the pools or even sort of the midpoints. It's always measured at that riffle crest or step feature or something like that. So it is in 3 parts. We're looking at the sinuosity, the width-to-depth ratio, and the gradient. You need a yes for all 3 in order for this question to be a yes. There are some examples where you may still have some of your sinuosity in place, but you've had some downcutting, which has changed the width-to-depth ratio. And then same thing, you may have a similar width-to-depth ratio, but if you've had some meander cutoffs, you've changed your gradient. And if any one of those is a no, then we're out of whack on at least one of those parts, and we're going to answer the question overall as a no. This is a question that doesn't have an option for an NA. Even if you're going through and doing PFC on a slot canyon where you really don't have the ability for the channel to change its sinuosity width-to-depth ratio or gradient, the way it's in that slot channel is still, you know, part of the potential, and so you would still answer it as a yes or a no, even though it's fairly well regulated through that site. So here's an example showing the idea of sinuosity. So we've got a valley coming through here, and you see the valley itself kind of turns, and that's what the yellow dashed line is showing. But the channel itself kind of meanders back and forth. It goes a little bit to the right of the line, a little bit to the left of the line. It has that squiggliness in there. That means that the stream is going a further distance to go to make the same drop as the valley. So the stream gradient is lower than the valley gradient. And so when would we maybe answer that as a no? What sort of things might we be looking for? So here's an extreme example on the left. The Walla Walla River, people like to farm. They like to farm in squares. They like to have water when they want it, not when they don't want it. So this river was regulated into a very straight channel with levees, so it didn't have access to a floodplain. It didn't have the appropriate sinuosity, so the appropriate pattern, And during a high flow, that energy came through, and instead of just going through like a nice calm stream like the Corps of Engineers would have wanted it to, it started hitting one bank, bouncing over, hitting the other bank, and then as that kept happening, it just sort of exaggerated itself, caused some erosion, and built that sinuosity back in for itself. And even though it's put that sinuosity back in, I'd argue that in that case, it's still probably not at the original sinuosity or channel pattern that it had been, or even if it's not original, it's probably still not yet back to stable. The image on the right is an image from Google Earth of the Humboldt River, right? Showing really high sinuosity through that system. So very, very low gradient valley leads to very high sinuosity typically. So along the Humboldt River, through portions, we've still got a really high level of sinuosity. There are other portions of the Humboldt River that have been artificially straightened, other parts of the river either related to that straightening or not, or other land uses that are now down cutting. So we've got, through a good portion of that river, we still have some of the sinuosity, but some of the other, the sinuosity, or sorry, the gradient and the width-depth ratio have changed. So even if you've got one of them that's still a yes, you're going to mark it as a no. So this is just sort of a quiz. I won't ask anybody to actually answer, but you know, for this item, sinuosity gradient and width-depth ratio are in balance. Just take a look at this and you know, come up in your own head what you think the answer would be. Would this be a yes or would it be a no? We would argue that it's a yes, right? So even though it's steep, you've got, you know, rocks popping up out of the water. If you were to look at this on a reach scale, it would be fairly straight, but that's okay based on the channel type. So this is somewhere on the order of a Roskin B, maybe a high end of it. So you've got a little bit of that step pool. You're not expecting a high level of sinuosity, and you expect sort of a high gradient. Item number 4, riparian area is expanding or has achieved potential extent. This is a sort of a two-optioner here. So you can see in this example, the word expanding has been circled. So in the left example, we've got a degraded site. The channel itself is fairly wide. We've got heavy use on the vegetation on either side. So if we were to do PFC on that photo on the left, we'd probably say no. Riparian area, it's not expanding, and it has also not achieved potential extent. And the reason we've got the two options there is, I believe early on wording said riparian area is expanding. And if you were at potential, then your site was no longer expanding, but that wasn't a bad thing in that case. So if you look at the photo on the right, in the time period between those two photos, and that is the same site, that riparian area had been expanding. In the photo on the right, it may have completed its expansion, but this is just an example of what expanding gets you from point A to point B. And expanding in terms of management and improvement of the riparian area is a good thing. And so we're showing that we're either recovering or that we have fully recovered. Here's an example where we'd circle that it's at potential. This channel is at the shape and the form and the position that it needs to be at for stability. We've got riparian vegetation right up to the water's edge. We don't expect that channel to be any narrower than it is. It's already a fairly narrow and deep channel based on the landscape and setting. As you move into the background there, you see the gradation from the herbaceous vegetation to the shrub-type woody vegetation to the more tree-type woody vegetation, showing a gradient as you go from really a high availability of groundwater. You go up in elevation off the channel, and you get a little less availability of groundwater. This site is at potential extent, and again, that's a good thing. That's where we're trying to get. But we don't want to miss out on saying yes when we're managing appropriately and getting to that point. Because if we've changed management and we're starting to improve, we want to be able to say yes and show that the management that we've changed to is causing improvement. Item 5, riparian impairment from the upstream or upland watershed is absent. You can see again in blue the struck out version of the old question. One of the biggest things that was a problem with that old question was that it only said upland. And if there was something that was a channel problem outside of your reach upstream that was causing degradation in your site, you couldn't answer it as a no in this just because the question specifically said upland. So it's been reworded to include upstream or upland. So there's, again, kind of two parts of that, and we'll go through a quick little example here. So on the left, the reason this is in here is for those of us in Nevada, this is a very typical upland site. Folks coming from outside of the region may see this and expect to see trees, and they may be concerned and say, okay, the upland site here is not at its fully functional capacity, so it may be causing some degradation at our site. But realistically, for our settings, grass and shrub up on those higher hillsides can be a healthy, functioning upland site. The image on the right, we've got a culvert coming out with erosion right underneath of it, and we put a no question mark here because there's a couple of things going on, and it depends on where you define your reach and what's really causing the erosion at that pipe. So even if you count your reach right up to just above that pipe, the pipe itself, it may be causing the erosion without any degradation of the watershed above it. So in that case, this would be a yes because it's not anything above the pipe causing an issue. However, let's say above that pipe, there's been pretty severe urbanization, and now you've got really, really flashy flows coming through that pipe, and where it hadn't been an issue previously, now it is. You may answer that as a yes because of the change of the condition of the upstream or upland site.
Actually, the reason for the question mark in my mind is that the obvious sediment supply being provided to the downstream places here may or may not get to the channel, and even if it gets to the channel, it may or may not cause degradation of the riparian zone down below. So even though there's obviously an erosion or sediment issue, the question is evaluated at the reach that you are on. It's not a question of whether there's excess erosion or a watershed issue in the watershed. It's, is there a problem of degradation on the reach we're studying?
So actually, I'm going to jump ahead a slide here just to show this flow chart that gets to what Sherm was just speaking to. If you're looking at your reach and you get to this question and you look around in the uplands and you see something in the uplands or something upstream that seems out of whack, there's an indication, or there's a tendency for people to want to write a no in here and say there is something out of whack upstream or in the uplands, and that is an issue. But what we're really looking at is whether or not that upland or upstream issue that you may see is causing an issue in your reach. So if everything else on your form is a yes, but you put a no for this question, you're going to want to go back and check yourself, because if overall your reach looks good, then no matter how bad the rest of the watershed is, that rest of the watershed isn't causing degradation in your site. So just going through, your first question here is there riparian degradation? If there's no degradation at all, then this question's probably going to be a yes, that the uplands or upstream are not causing degradation in your site. Otherwise, you would have said that there is degradation, right? So then on the opposite side, if we ask, is there degradation, and we say yes, then we still need to qualify it and say, okay, for the degradation that we're seeing in the reach that we're assessing, is that degradation coming from within our reach? Are we seeing erosional features, or is it a lack of vegetation or something that's occurring within the site that we're assessing? Or are we seeing an issue that's coming from upland or upstream? And you may have both, but in this case, if all you're seeing is degradation that's fully within the site you're assessing, this question may still be a yes if it's not directly caused by something upland or upstream. And then we'll just go back to this example here. So on the left, this trapping creek, what we've got here is an excess of sediment, and you can see in the photo we've got a little bit of erosion on some steep banks there, but the majority of that sediment is not coming from that site. It's coming from an upstream issue that's outside of the reach that was being assessed. In the photo on the right, we've got some coarse material, we've got some woody material in the stream, but that's what would be expected for that stream type, and we don't see any evidence of anything coming from upstream or from the upland sites that's leading to degradation in that reach. So on to the vegetation items, and Sherm, we'll let him step in for that.
Okay. So any questions about anything John said?